Hi, and welcome to the November edition of Kontena online meetup. Today's topic is managing secrets and SSL certificates in Docker containers, and of course the main demonstration part will be using Kontena platform to do that. We all know when working with containers that managing the configuration and especially the secrets can be a bit troublesome with, and you really need to have a solid centralized way to manage your secret and easily push those changes to your running containers. In next 40 minutes or so, I'm gonna show a couple of examples how to do it with containers, and then of course demonstrate and show examples how it works with Kontena, and also explain how it's actually working within Kontena to give you a better understanding about the security features, how it really works, and how Kontena makes it really secure and easy to use. So today I don't have really slide material, so today I'm gonna be working mostly in terminal to really show how it really works. So let's switch to my terminal mode and see how it really works. I do have some kind of notes mainly for myself and also for you to see some information in text form. So one option for storing your secret information is of course put them in your Docker images. So what I could do is I can go to my Docker file, which in this session I'm going to use this Mattermost, which is kind of a open source version of Slack. I'm going to use that as an example, but I could go actually to my Docker file for the Mattermost application and say that in this environment I have my database password equals some secret. This would of course create me a working setup if I configure my database side also the same way. But of course we all know that this is really a bad idea, because whatever you put in Docker image is really extremely hard to take it out. Even though on later stages in the image I could do some kind of remove the variable by using some empty string, for example, for it. Because Docker images are layered, so the layers are always present in the image. They're just not seen in the container running from the image, but the data is actually still there within the image layer. So it's extremely hard to take out. There are some tools to take out image layers, but they are not that easy to use, and they are quite time consuming also, because they have to do all this extracting and kind of remaking the image and everything. So it's not really good idea to have that also in your build pipeline, for example. So okay, that's really not a good idea, so let's not do that. One other option would be to use these environment variables directly when running Docker. So you can say that, okay, MySQL password equals my secret password or something, and just run the MySQL image, for example. This of course works. It's not exposed in the image itself, But it's quite hard to scale this up and keep up your configuration, especially when you are running with your Docker containers across multiple different hosts. So how can you be sure that you are actually using the exact same password for all your containers? And then if you, for example, suspect that you have had a leak of your password, or your password has been compromised in some way, it's really difficult to go and change these afterwards. Of course, it's not even possible with Docker, at least as far as I know. So what you have to do really is you have to destroy the old containers and run new containers with the new password setup. So that's not really a good idea either. One better idea is to use this environment file. So it's supported both by plain Docker run and also supported in Docker Compose, of course. So you could then have this at least kind of centralized storage for your passwords and secrets, whatever your secrets are, whether they can be API keys or SSL certificates or whatever information you want to keep secret from plain users. So you can store them in the environment file, but then you have to figure out where do you store the environment file so that it's actually even remotely secure. So you cannot really store that within your version control system. It's not really secure, and it's kind of a really bad idea. And then also when you are running your containers in different hosts and different environments, how would you actually distribute the environment file across different hosts and environments? For that you would then have to use some other configuration management tools like Ansible or Puppet or Chef or whatnot. So even though a bit manageable solution, it's really not that good either that way. So we really want to have a centralized secret management solution for your containers and for your containerized applications. And not only centralized, but we want it to be really secure also, so that the secret data should be always secure, so it shouldn't be stored or sent anywhere in plain text, of course, and also so that we have clear auditable logs of who's been using and who's been updating, changing, removing our secrets, so that we can really see if or see possible compromises for our secrets. So, pretty please, there are actually some solutions out there to fulfill this sort of a requirement. Some of the options I just collected quickly. HashiCorp has a product called Vault, which is really a solution for this centralized secret management. Vault can do also other things, so you can actually use the HashiCorp Vault for this sort of a general purpose encryption usage also. So you can actually encrypt basically any data with the Vault. When I quickly looked with Google, of course, there seems to be some almost ready-made solutions how to integrate the HashiCorp Vault into container environments. For example, I saw that there is some integration for Kubernetes platform, for example. But to use the vault secrets in plain Docker environment, you have to do some automation yourself. So although that's as a sort of a solution, the vault looks really great. It sort of lacks the automatic integration to the container platform, at least as far as I know. Kubernetes orchestration platform also has this secrets management concept. The only problem that I can see with Kubernetes secrets is that they are not actually so secret, because they are still stored in plain text in the etcd key value store. There is an active discussion, and I think I saw an active pull request also to make it encrypted in the etcd. Docker itself is also building secret management into the new swarm mode. Not sure where in what release it's going to be available, but at least it's not in the latest releases yet, so it's still under discussion, and hopefully Docker will have it in future releases. Of course, there's always an option, this DUI option, so you can really you can do it yourself, of course, but nowadays one should always make the question that why should I do it ourselves if there are some other options available, because managing secrets is not that easy, since you have to make sure that the data is actually always secure and it's not leaked anywhere. And as with any container orchestration platform, it's not really a good idea to do it yourself anymore, because there are plenty of good options available. Of course, Kontena being the best one of those. And then, of course, as I'm gonna show in few minutes, Kontena also has this component called Vault, which can securely store secrets and then push those secrets into running containers. Just a quick intro how the Kontena Vault works internally, kind of quite a high level overview before I jump to the actual demo part. So in Kontena environment, we always have a master and some number of nodes which are running the Kontena agent. The secrets are stored in the master database, and they are actually encrypted with AES 256 CBC encryption while at rest on the master database. So it's pretty secure and good encryption for those while at rest. And then when the user interacts with the CLI tool towards the master, the traffic is always encrypted with TLS. So the secrets are not flying around the internet in plain text. And then when the agent is starting some of your service containers which need these secrets, the information is always transferred between the master and agent, also within a TLS layer. So there also it's really secure also. And then of course on the agent side, the agent kind of injects the secrets then to the running container. So the agent itself doesn't actually store the secrets in any way. It just kind of injects them into the containers when starting up those. So it should be, well, it is secure from A to B to C. So the traffic is encrypted in all stages. Okay, so let's see how in practice how it works with Kontena. So as I mentioned, as an example, I have this Mattermost application. So it's Mattermost is the kind of open source version, or not version, but open source Slack type of application for online chatting and those sort of online communication. I'm not going to really dive deep into the Mattermost application itself because it's not the topic for today, but let's see how it's deployed with some secrets. Let's start actually from the bottom. So in this Mattermost deployment example, I have MariaDB database, which is, of course, uses some secrets. So in the Kontena service YAML configuration, we can define that okay, this database service now really needs some and uses some secrets. In Kontena YAML, the secret is always defined with the name, so the name identifies the secret. Then you can say that what's the kind of internal name for the container, or how the container sees this secret in its environment. And currently the only type that we support is this environment injection. So in this example, whatever I write into the Kontena vault as the Mattermost MySQL root password will be seen in the MariaDB container with the environment variable named MySQL root password. So it gives this kind of name aliasing gives you flexibility to easily reuse your secrets between different services and different types of containers. Because you can actually, you don't have to have one single unique name for your MySQL root password, because maybe some other container uses the same database password with some other environment name. So for the database, I have two different passwords defined. I have this MySQL root password and the password for the Mattermost database itself. And then in the Mattermost application part, I have this, of course, using the same password for the MySQL database, or sorry, MariaDB database. And in the application side, now you can see the aliasing in action. So the application actually sees the password as in database underscore password in the container environment variables. So now to be able to deploy this, of course, I have to create the secrets. So I'll take a copy paste of that, switch to the terminal. The vault should be empty. Yes, it's empty. So let's write the password for the MySQL root password and give some long enough random string so it's not easily broken. And now the CLI interacted with the master through TLS encrypted HTTP. So it was secure all the way, and now on the master database it's now encrypted with the AES encryption. Let's write the other one also. Let's try to make no typos. And again some random string. Yes, that's also now safely stored in the Kontena vault. So now we have configured all the secrets that we need. All the other configuration, of course, it's done also in the same YAML file. So I have this couple of other environment variables for the application to say that, okay, where is the database running? So what's the DNS name within the Kontena secure overlay network for the database container? Then what's the database to use, database user? And then I have also in this example a load balancer in front of the application itself, and later I'm going to show how to configure the load balancer with a secret to actually terminate even SSL traffic for us. Then as a post start hook, there is this init configuration script. So it basically is run after the application container instances have been deployed. The Kontena platform runs the initializing script within the container, which then of course initializes the application environment. So for your own applications, you could use these post start hooks to do any sort of a initialization, database migration, database seeding type of work. The database is quite straightforward also. So we are running the latest MariaDB version. We flag it as stateful because of course we want to have the data persisted. So the stateful flag now makes sure that in Kontena platform that the data is persistently, even if I redeploy the whole database service itself. So the data is actually then mounted from a persistent volume to the database service container. And then of course the secrets that I just wrote to the vault, and then a couple of environment variables to define the user and the database for the application. Pretty straightforward, simple application to deploy. So let's deploy it. So the CLI is now interacting with the Kontena master. It created the load balancer service, created the DB, created the application. It deployed already the load balancer itself, deployed the database service, and deployed the application itself. So now again, if we look at the configuration, we didn't actually expose any ports out of this application and database, of course, because we don't really want to expose those to the internet directly. So only thing that we actually exposed from these services is the load balancer. So when checking the load balancer configuration, I can now then pick up this public IP of the load balancer, and what I should see is that the Mattermost application is now up and running. I won't dive into the application itself as said, because that's not the beef for today. Nice. What Kontena also does with the secrets management is of course this audit logging. So I can actually go to the Kontena CLI and ask for the audit logs for the grid. And as you can see in the audit log, there are entries that I've created these just now, these MySQL passwords for the root and for the plain user. You can of course see that I just before we started this online meetup, I cleaned up my environment, so you can see that I deleted them. So all the actions towards the secrets in the Kontena vault are really logged in the audit log. Now, what I could do, of course, is I could update the password, for example. I'll grab let's change the root password, for example. Let's change it to something. Me randomly typing, I'm pretty sure that it actually did change. So now the vault is actually updated. And when we look at the database service of the application stack, you can actually see that while I updated my secret data in the vault, Kontena platform of course knows that there are some services that are using this secret. So the Kontena platform automatically reconfigures and if needed, redeploys your services. So this gives you a really handy tool to rotate your secrets if there has been any compromises or if you have so strict rules that you have to actually rotate your passwords or API keys or whatnot in certain time frames. So it's really handy that the Kontena platform itself takes care of that for you, so you don't have to actually then do any redeploys yourself, so it's automatically deployed. Okay, that's about the sort of basic secrets, and as you saw, using them is fairly straightforward and easy. And as explained, the data is always encrypted at transit and at rest, so it's also quite secure to use. But then you could of course use those plain Kontena vault commands and the Kontena vault as such to manage your SSL certificates. So if you have already existing certificates, you can of course then just import them into the vault and use them as any other secret. So the Kontena vault of course doesn't really care what the data is. It can be really anything. But to make the certificate handling even easier, we've done an integration to the Let's Encrypt certificate provider. For those of you who hasn't heard about Let's Encrypt, it's an free to use certificate authority and certificate provider, which is I think almost fully trusted with at least with most client software out there nowadays. So you can really get free certificates which are actually trusted by browsers and most other client software also for free, and that's really nice. So the integration with Let's Encrypt in Kontena uses this domain-based challenge verification process. So basically, the user interacting with the Kontena CLI makes requests for the Kontena master that okay, now we want to have certificates from Let's Encrypt, and then the master stores some bits and pieces of the information and then interacts with the Let's Encrypt API to create these authorizations and then finally get all the certificates. I'm gonna jump back to the terminal to really show the certificate management in action. So again, it's the first step is to register myself to the Let's Encrypt side. So what this actually creates me is a private key and registers that private key into the Let's Encrypt, so that Let's Encrypt can really trust that the traffic is coming from me. Then the second step, and this registration has to be of course done only once per environment. And if you have already registered previously to Let's Encrypt and already have a working private key, you can actually then import that also into Kontena platform. So you don't have to always re-register if you don't want to. But at least I haven't seen any downsides also registering again and again and again for Let's Encrypt. So the second step is to authorize or initiate the authorization process, because of course Let's Encrypt has to have some way to figure out that I can actually control and I'm authorized to get certificates for the domain that I'm requesting it. So the Kontena integration uses the DNS-based authorization process. So let's create that authorization now. I'm using this mm-demo.kontena.io domain. So now again, we are interacting with the Let's Encrypt API that okay, we would like to have a certificate for this domain. And the Let's Encrypt then replies that okay, cool. I'll give you that after you fulfill this challenge. So the challenge now is to create a special TXT DNS record with this special acme-challenge subdomain of the domain that I requested in. So the Let's Encrypt then of course trusts that if I'm able to fulfill this challenge, I am certainly in control of the domain. So let's grab that one and go to our Route 53 DNS management in Amazon. So let's create a record set. This Acme challenge type of course was TXT, and the content, let's grab that with copy paste. Let's put really short time to live so that it's fastly updated across the DNS systems. That's created. Yes, that's there. And now we have fulfilled the challenge. So what we can do now is we can actually go and get the actual certificate itself. It takes a few seconds because the Kontena platform also verifies that okay, you have fulfilled the challenge, and then again the Let's Encrypt also makes the DNS queries across different set of DNS providers and sees that you actually have fulfilled your challenge. And now when we get the certificate, as the message says in the console, the integration in Kontena side, it automatically creates 3 different secrets for you. So the first one is the private key part of the certificate. So that's stored in separate secret. The certificate is another secret. So that's the plain only the certificate itself. And then we automatically create this third one, which is called this bundle. So that's basically a bundle of the private key and the certificate formatted so that it's ready to be used with the Kontena load balancer. The Kontena load balancer is based on HA proxy, and whoever has been working with HA proxy knows that HA proxy can be and has been at least in the past really extremely picky about the certificate formats. So that's why we make the life of users more easy so that we actually create this ready-made bundle. And the certificate by default is a full chain version of the certificate. So it has the full chain of authorities and signers in the certificate itself. You can configure, use these different options. This certificate cert type option in the CLI to specify what type of certificate you want to have. You want to have the full chain or the partial chain or just the plain certificate itself. But using the full chain typically is the best option to increase the sort of validity of the certificate across different client software. Okay, so we have the certificate in the vault. So how do we then configure the load balancer to actually terminate the SSL traffic for us? So of course I'll make a copy paste of this. So the Kontena load balancer of course expects to have the SSL certificates in an environment variable called SSL certs. And then let's just grab the bundled version, and that's it. So that now really gives us that small secret configuration in the load balancer gives us a load balancer which can then terminate SSL traffic for us, which is pretty cool and really simple to configure now. Of course, we have to now deploy the load balancer. I'm deploying now only the load balancer service because I know that I didn't change any other service. Yep, the load balancer is now updated, so the configuration is automatically updated, and now it should be able to serve as HTTP version of the Mattermost also. Yes, of course now my browser complains because I'm using the plain IP. But if I go again to the route 53 service, I'll create this demo domain with of course an A record for the IPv4 address. Let's put a short time to live again to have it really updated. Okay, so the domain record is created. So let's go to this mm-demo kontena.io. Some weirdness in the Mattermost application itself, but let's not mind that because we are not really interested in the app Mattermost itself. But what you can see now in the browser that we really have a valid certificate signed by Let's Encrypt and issued for the mm-demo.kontena.io. So, and again, we are, of course, improving the Kontena platform all the time, and one of the features that we will be improving in near future is the certificate management part, so that we will have the certificates automatically updated by the platform itself. Because as you see in the certificate information, the Let's Encrypt gives you only certificates which are valid only for 3 months. So it's pretty short time frame. And of course, changing certificates in every 3 months is a bit of a pain in the behind, especially if you are not using this Kontena secrets management solution. But what you could actually do already is that whenever you receive the email that your certificate is about to be expired in next few days, you can just go and issue the new certificate getting operation, because we already have the DNS challenge in place. So the Let's Encrypt still trusts us that okay, we still are in control of the domain. And as you remember, when I showed how to update the secrets, so whenever the certificate integration part actually then updates your certificate, it automatically triggers a deployment of your dependent services which are using that secret, and voila, you have automatically updated your configuration, all your certificates, all your application which are using that certificate basically with a one single command. Okay, so that's about it from the secrets and certificate management point of view. As you saw, it's really easy to manage your secrets with Kontena platform. Kontena makes it really trivial and still secure and an auditable way to control your secrets. To stay up to it with Kontena, find us on Twitter. We do have a Slack channel, slack.kontena.io. Of course, Kontena platform is fully open source, so go to GitHub, find Kontena, repost there. We do have plenty of different meetup groups around the world, so join the local meetup groups also. And of course, we'll be hosting these online meetups in coming weeks also with some different topics. And of course, go to kontena.io website and you can find plenty of information and documentation on there. So on my part, thank you for joining this online meetup and hope to see you soon in the upcoming meetups also. Bye.